Welcome to the session. Greeting of the day. In today's class we are going to see about the other mechanical energy welding processes. It means in earlier classes we have seen about the gas welding methods, and later we have seen about the arc welding methods of SMIW, SIW, GTW, mix we have seen, and later the resistance welding process of spot, seam, projections also, the various types we have did. Is this all classification with respect to source of heat, how it is generated. This gas with respect to flames, this arc welding with respect to electrical arc, this resistance welding process with respect to resistance heating, and mechanical energy welding process of solid state with respect to various mechanical forms. In such case of friction weldings, in such case of explosives, in such case of rolling, in such case of forging, we are there. On that we have already completed about this friction process. Due to the mechanical action of friction, heating, the rubbing action, the welding will occur. That we have seen. Now in today's class we are going to say about the other methods of explosive welding process. We are going to see. In continuous with that, the forging, the rollings and all yet to be studied. The other processes are there. Number this, the explosive welding methods. In this explosive welding process, it is a solid state welding. It is a solid state welding process. It means we are not going to melt the material. We are going to make the welding. It means joining of two components in the semi-solid plastically deformable condition. How it happens? It is used for the heating purposes, explosive. That we know, the name says explosive. The heating source is explosive energy we are going to use. So how it is used for metallurgically dissimilar materials welding process. We can use, there is one word of a name, cladding. The name cladding is there. It is given here, the cladding. It means we want to paste or we want to attach one more material over the other. That is called as cladding treatment. In the boiler components, due to this steam process of hot conditions, the material will start to erode or start to corrode will happen, corrosions will happen. To avoid those things, the entire boiler plant making in the stainless steel, we know stainless steel is a corrosion resistance material. And therefore, the entire boiler components cannot be made with respect to stainless steel, but the pressure maintenance and mechanical energy process are very important here. See, we have taken one boiler component and it contains a thickness. It contains a thickness of to withstand high pressures. With this withstand high pressures, we have a thickness of 20 mm thickness plate. We have bended and we have done a submerged arc welding at the top. Submerged arc welding at the top we have did. Now inside the turbo boiler steam heat exchanging process will happen at the inside boiler plant. Due to this high heat process, the inner part of the boiler plant will get corrosion. Due to this corrosion, this 20 mm thickness plate, this 20 mm thickness plate this 20 mm thickness plate will start to corrode, as because mild steel does not have that much corrosion resistance. Therefore, in the stainless steel we are adding the chromium content greater than 12% to make it as a corrosion resistance material. That is how the stainless steel converted into stainless steel, that we know that part. So I want to make a corrosion resistance boiler. How we can able to do? We can't able to do such large thickness 20 mm thick plate welding is not recommended, as it is very high cost and also depend upon the large thickness it increases. Therefore what I am doing the cladding process. I am doing this cladding process on the plate itself first. This is the plate of 20 mm I have taken and I am doing this cladding treatment now. How I am doing? I am doing the cladding treatment here for 2 mm or 3 mm here. Slowly I am doing the cladding treatment here. So I have did this. Using this explosive welding method. Using this explosive welding method, I have did the cladding treatment. Now I want to bend this and I can able to make the component of welding. So this component is ready now. So small minute layer of stainless steel is attached over inside. Stainless steel attached here, and above that I have bended this. I have bended these things. See, at the outer part we have this component now. At outer part we have this mild steel. So this one is mild steel, and inside part we have this okay, you understand, I think. So see, so this is how the large thickness of mild steel we have outside. So inside thickness plate, inside we have the stainless steel component. So now the stainless steel has been cladded over the outside 20 mm thickness. This is having the thickness of 5 mm. This is having the thickness of 20 mm. But 20 mm thickness, according to it is mild steel, the cost effective. But the stainless steel is high cost due to the presence of chromium. And therefore we can't able to use this entire stainless steel for 20 mm. Cost increase during the production. Therefore, I have taken this mild steel, I have cladded the stainless steel, and I have bended, I have welded, and I am using for the boiler plant. So this cladding treatment can be done. This cladding treatment can be done by using this explosive welding process. That is what I have given. The metallurgically dissimilar material welding process. Steel with the stainless steel I am joining. Similarly, some others. Stainless steel with the titanium, titanium with the copper, aluminum with the steel, some combination according to the I have taken example of boiler plant. So some other examples also we can able to do. So this cladding treatment is done by using this explosive welding methods. Buffer layer protect the frame component from the corrosion due to explosive placed on the frame component. Frame component is nothing but inside. Some other layers it is protecting. The buffer layer protect the frame component from the corrosion due to explosive placed in the due to this explosive and heats it will be corroded. So that is what we are avoiding. Heat generation plastic flow. Above two are due to the explosion that are causing high velocity impact on the cladding component with the heat and the plastic flow at the interface that forms the metallurgical bonding. Cleaning requirement avoided by the oxidations. So I am making some basic steps over here. How we can able to do what are the components first we are using. I have taken the base material, first component. I am explaining the procedure of doing the explosive welding process. See, this we are doing. Here one component is there. Here the one component is there. And one more component we have collected this small light color. This is the second component. And I am making the explosive here. Due to this explosive, the force will be generated and it will be false here. It will impinge here. It will impinge here. It will impinge here, and it is fixed there. It is bonded. Metallurgical bonding takes place. Explosive energy used for heat, and either heat is utilized for welding purposes with respect to high velocity. That we will see. So base material, I have taken one component of base material here. I have taken one component of base material, a stationary. The frame cladding material is to be welded in it. So in one more component I have to take here. That is called as cladding material. That is what our concept also. Cladding material to be pasted over there. Stainless steel to be welded over the normal mild steel. So I am taking one more material. Of one more material I have taken, that is called as a cladding material, which thickness is very less. which thickness is very less. Here the thickness is high, 20 mm, maybe that is a 5 mm or 6 mm that we can consider. The positioning the parallel, positioning it to the parallel or with some angles or with some like this angles also we can keep to like closing method we can able to make to the base component. Right now, at that we are attaching the explosive now. The garnular form placed over the prime component. Prime component is nothing but a cladding material. Prime component. Prime component impact develops upon type and quality of the explosive. So I am making here this firing. The explosive are kept fired. Due to that what happens? This fire creates like a blasting force, and that force will be applied over this cladded material. Due to that force, like a rocket, when we are firing, it goes upward. I'm firing here, it comes downwards. So the force generated there. So the force makes to impinge over this side. Force generated impinge over this side. When the fire is delivered, the fire is explosive is kept here. The explosive is continuously kept here throughout. The above layers are covered by the explosives. So there are two layers are there. One is cladding material, and over there we have the explosive. At one point I am firing. Immediately the fires will keep on going there. While it is keep on going, it generates impact. This is impinged, again this is impinged. So it continuously happens, and impinging force creates the cladding welding. So explosive. So buffer layer, it is one of the layer between the explosive and the cladding material. So see, this explosive, there is a chance to make damage of the cladding material. Therefore what I am doing, in simple I would like to make one small cladding gap buffer layer, a powder or some other small component I am adding there. So that makes a difference or protect the cladding material from the explosive. A layer between the explosive and the cladding material to prevent surface from the erosion by the explosive. Therefore, I am preventing. Explosive nothing but RDX some types. So standoff distance may be 0.5 to 1 times of the thickness of the prime component. So standoff distance, how much parallel we can keep as the thickness we can able to keep there the gap. So this is what I have delivered now. So we have kept parallel two specimens. One is the base material, and then this belongs to the component of clad material, and above we have one more layer. See this layer, the explosives, and then the starting point, the detonator starting point. It may be parallel, the distance equal to the prime component, how much cladding thickness, that gap I am leaving, and then here also it may be the angular format. Okay, the clearance gap. Whatever it is, we can give. Here you can able to see, here the buffer layer is not given. A buffer layer to protect the cladding material. Okay, so I have added some buffer layer here, you see. So buffer layer is there. Base material, the cladding material, the buffer layer, and the explosive. It is started, fire, explosion, and blasting with high velocity. It impinges over there, and the cladding process will happen. So this is what? It is a solid state metal joining process that uses explosive force to create metallurgical bonding between two components. So that is how we can able to do. See the workpiece, the fly over the cladders and the explosive. I am starting the explosive here. See, it impinges here, it goes here. It impinges here, it goes there. It impinges there, it goes there. So it is a continuous process. When the explosive started here, it keep on, explosive will blast there. So simultaneously velocity will be created, simultaneously it is impinge over there. So that is what? The chemical explosives. The steps. Now I want to deliver how we can make converting these steps in simple form. We understand the concept. The steps involved are, you see, the number one, plain material inspection. First, we have to take the plate first. First, we have taken the plate. Step one, how the plates are created and formed, smooth surface, flat of thickness and this cladding, all this arrangement has been done. Ready. And then the graining of the surfaces, if required side borders, surfaces, irregularities, those things are grained. So graining also done. The assembling of baker, cladder and explosive, all things are assembled. Baking plate first base material, then cladding. We have taken over there first base material taken separately, everything is done separately. Then we are placing over there base material, cladding, buffer, explosive, all ready, assembling. So that is assembling is over. And next, flattening and cutting process. Even this here one more process, what we need to do? We have to do the welding methods. Here the welding will be there. Step 3A, welding. After completing the welding methods, we should do this. Welding over. After welding, we should make the flattening and cutting process. So the required side edges to be cutted. And then finally, if required, we can go for testing and inspections. So that is what. So assembling, graining, assembling, and then the welding process will take place. At last, you see here how the blast happens and comes quickly as a jet forces. Then if required, we can go for flattening and cutting, straightening, because due to this impact sometimes the base material also got distorted due to high force of heat, high force of velocity impinging. Therefore it should be flattened well. And then the flattening is done, and then next the testing process can be done. So this steps it is important. Number one, plain material inspection, the graining the surfaces, assembling the all base material, cladding, buffer and the explosives all assembled, then the welding and flattening, it means the rolling process and flattening, and then the testing and the inspections to be done. Due to short time duration, the theory, due to short time duration of impact, there is a adiabatic heat rising will takes place, and therefore during explosion on the flyer plate, the high pressure pulse is generated. This pulse propels the flyer. This pulse propels the flyer plate at a very high velocity. Yes. The jet of the product is collision of the two metal surfaces at the bottom. So jet formation allows two pure metallic surfaces to join under extremely high pressure. How it is generated? Due to this jet action of the explosive, due to this heat rise, due to this pulsed jet propulsion of takes place and it's impinged. So that is how we can able to understand. What are the other explosives that we are using? Such few names I have given. So high velocity explosives, some are there like TNTs, RDX, patterns, or some other there which consumes velocity of 7,620 meters per second blasting process, very high, very powerful RDX, these names we have here. So high velocity. Similarly, the low velocity speeds for the thicker sections, thinner sections we can use. Some other ammonium nitrates, ammonium perchlorate, some others we can use for which contains a 4,572 meter per second velocity it will generate. Should be handled carefully, otherwise the industry which we are storeroom will getting blast. The entire industry will be spoiled over there. It should be done at a remote location. This welding process should be done at a remote location. To be carefully, we should do this. So velocity of impact to be greater than that of the critical velocity. So sometimes if the velocity is very low, the crackers are started and slowly it is blasting. There is no use of impinging will not take place. Therefore, we should high than that of the critical velocity. How much it is? So velocity is equal to 500 meter per second at least we need. This RDS content which is 7,000, that much force we have. The component, the volume we should use very minimum In such a way, it can able to generate 500 meter per second force or velocity. It will go. Such velocity we need. Below that, it will be critical. It won't, welding will not happen. So what is the example that welding is not happen? So I have taken one aluminum component, I have taken one steel component. On this two, I have do the cladding process. Explosive welding has been done. You can see here, the layers are not bonded. It's very minimum. When I am comparing this copper and steel, both the steel of base material has been large thickness has been taken, and then I am cladding one on aluminum, one on copper. Here there is a flat surface. You see, there is a flat. There is no such impinging process has been taken place. But here you can see some impinging process are taken. Some impinging process has been taken. This is stronger than that of that aluminum steel cladding treatments. So which one it decides the softness, the thickness, and the yield strength? This decides the interlocking formation based upon this aluminum and steel and the copper's softness. How soft it will become? Aluminum will become softer. So how thickness we are using? Stainless steel thickness is large one, and thickness of the aluminum or copper is medium thinner one. And based upon the strength factor of these two, all these three factors, the interlocking formation, which what is called as interlocking? This is interlocking. So interlocking of copper and steel takes place here. Interlocking takes place. So this interlocking from the wave pattern, which helps in good bonding. So this is bad bonding. So this bonding is not good. Here this is very good. So accordingly, the cladding metals are flat like this. Cladding metals are flat at less velocity. So less velocity is less than 500. Critical velocity to be higher than that, not to be less than critical. Greater than 500. Limited mechanical interlocking will not be there. If the velocity is not there, mechanical interlocking, this interlocking methods will not happen because force velocity is not there. So, and poor, it will induce in the poor strength also. So that is how we should taken care. So the same interlocking methods I have shown you here. See, this is interlocking. So likewise, it should impinge over there. It should impinge. So the same similar some images, I have metallurgical images I want to show you. See, some interlocking methods are happen. So what is the welding variables, process variables for this making this explosive welding? Type and amount of explosive. What type it is? Whether heavy explosive, lightweight explosive. The type and amount, how much volume we are using, based upon the thickness of the cladding component. Cladding is the upper component, and also thickness of the base material. We have to mechanical properties of the cladding component, how far it is ductile, or how much thickness, how much softness, how it can be. So this point we have seen here. This point, softness, thickness, and yield strength of the cladding material. We will decide the interlocking methods. Standoff distance, how much it is how much gap we are giving between these two. Standoff, how force, minimum force, high force, it should reach high velocity we need there. Welding variables, collision, therefore how much velocity we need to impinge the critical velocity. So collision velocity, the collision angle, whether it is a parallel or it is angle closing. And the cladding component velocity, how much it is we are doing. So such examples. So advantages. You see, this image you please note it down. There are two components we have welded, 1 and 2. Here you can see that it is not cladded properly, it is not welded properly. We have a break here. See, so that how we should check after cladding treatment, we should check for testings whether it is properly cladded or not. Otherwise it is like tear out. It will tear out in immediate after welding. No use of that. So advantages, joining of dissimilar materials. Stainless steel with aluminum, stainless steel with copper, with titanium. So those things. So that is what, stainless with titanium, titanium with copper, aluminum with steel. So such a process we can able to, dissimilar cladding process we can able to do. Area of joint size can be vary from small to large sizes. A large component we can able to weld. A thickness of the frame component, clad component is from 0.25 to 30 mm. Thickness, maximum thickness of the frame is nothing but a cladding component. Cladding we already told you it is a 30 mm. We have, for example, we have taken a large mm of 20 and we have cladded the 5 mm of thin sheet, but possibly we can go up to 30 mm of cladding material also. So that's how the advantages are there. What are the limitations or disadvantages? It is suitable for flat geometry only flat cladding, only flat closing, flat. Okay, it's not angular or this and that. We can't able to do. Lap joint configurations, one over the other. Lap joint. That is what we are doing. Lap joints. Noise and blast required due to this cracking process of blasting. Due to this explosive, it creates noise and blasting of performance also it will do. Cladding plate cannot be too large, and the metal must have high enough impact resistance or the ductility. It means metal must have high enough of impact resistance and ductility. The base material should have high impact resistance. Otherwise, when we are giving from the 500 meter per second, it will comes forcefully, and this should not break here. It should not break here. If it is breaking, then there is a cladding will not happen. It is a waste of time. Therefore, these things should be taken care. What is the application then? Specifically, we know it is used for cladding process. We are using in the border plants pressure vessels head by explosive weldings, cladding of steel nozzles with the stainless steels, heat exchangers, tube to tube joinings, lap joinings, pipeline weldings, all done from the plate. We are generating the pipe. The plate cladded and then bended. Submerged arc welding can be done. Pipe weldings, build up and repairs, cladding of the carbon steel plate with a thin layer of corrosion resistance. So see, this assembled source, various components are here. So the various components can be welded with respect to these combinations. Mostly all components are matching. Carbon with zirconium, straight stainless steel with the calcium, gold, silver with copper, nickels, all are matching. So many possibilities we can able to do. So I would like to play a small video here for your references.
Explosion welding is a solid-state joining process that's accomplished by accelerating one metal into another metal at an extremely high velocity using high-energy explosives. Metal is a key component in high-stakes industrial infrastructure projects around the world. For these types of applications, the metal must meet a very specific criteria. Explosion welding offers an economic way to leverage the dual benefits of both metals while retaining their mechanical, electrical, and corrosion properties. Explosion welding allows for over 260 metal combinations, including these metal types. The proprietary data-clad explosion welding process begins with a thorough inspection of the materials. Then, grinding the surface of each metal ensures that they're free from any debris, oxides, and surface flaws. The thicker of the two metals is called the backer, the thinner layer, the cladder. The detonation is initiated, driving one metal towards another, producing a precise collision angle and velocity. These factors are crucial in creating a jet in which all oxides and impurities are expelled. The jet not only sweeps the plate surface clean, but creates the ideal conditions for a weld. The backer and cladder come together to produce the end product, explosion welded clad. In preparation for delivery, the explosion welded clad plates undergo a finishing process that can include heating, cutting, or flattening. All clad undergoes stringent testing and qualification to ensure it meets industrial and project specifications. Once the products are inspected and certified to industry standards, we deliver them to customers around the world. From design to execution to final delivery, we are the global leader in explosion welded clad.
Okay. Achtung, geht los.
Right, the summary. In welding, in also solid state welding, we have seen about the explosive welding process. Useful for cladding and their advantages, applications. The remaining part of the subject, we'll see you in the next session. Thank you.